How many people here have internet connectivity? How many people don't? Gosh, okay. Well, I don't. I don't know if I got here too late. I rebooted my computer and I still can't get on the network. So rather than try to move ahead, I typed in the URL here for the repo that the notebooks that I've created for this are. I was going to show you what those looked like, but I can't get to the internet, so you should see a list of files there that looks something like that. So I'll keep over. This is going to be. I apologize for the makeshift nature of this, but everything I tried to connect to the internet failed. So anyone not yet connected or able to access that URL, it's github.com/gumption/PyData-Simpsons. Raise your hand if you haven't gotten there. Okay. When you get there, I recommend that you open up the notebook that has clean in capital letters. PyData tutorial Simpsons clean IPYNB notebook. Actually, you'll need to grab the notebooks and then open them up. But this is the one that I'll be driving the presentation from, is the clean notebook. Anyone not able to access the URL, the repo? Anyone not there yet? Okay. I've also created some additional files there for those who don't have everything installed already. There's an HTML version, so in the worst case, if you're not able to get the notebook and get it all set up, then you can at least follow along through an HTML version in a browser. Meanwhile, I'm going to see if I can connect on this one. I'm going to see if I can get on this just in case. Huh, weird. All right. For some reason, I'm allowed, oops. I can get on this notebook. Let me try again here. All right, well. Well, I'm not quite sure how to run this. I've got a spare notebook here that I seem to be able to access. So I guess I'll Okay, so is everyone there at the repository? Okay, if you clone the repository and you set it up somewhere on your computer, then I'm going to just still drive it from my other laptop here, but that's what you should see. And then, as I said, if you have trouble downloading, you can still. Whoops. Darn. Okay, so you have to you'll have to download that file as well in order to be able to render it. Okay, I'm going to jump back over this one. Okay, so I apologize for the rather slow start here. I'm delighted to be here. My name is Joe McCarthy, and I'm a data scientist with Indeed. I help people get jobs, and sometimes I help people learn something about Python and data analysis. Indeed is a sponsor for this conference, so I hope you'll stop by and see us at the booth. As I suspect many of the people presenting here at the conference, or many of the organizations that are sponsoring or otherwise participating, we are hiring people who know Python and data science and so on. We're also giving away a drone, or raffling off a drone. So if you stop by our booth sometime during the conference, we'll be raffling that off, I think at lunchtime on Friday. So can everyone read this, or do I need to increase the font further? In the back, can you read it? Okay, great. So I proposed this tutorial for a variety of motivations. One is that I have unevenly spaced opportunities to do unevenly spaced time series data analysis. I don't do it often enough so that, oh yeah, I know right what to do. I need to go find whatever notebook I was using in order to open it up and figure out, oh yeah, those are the techniques I was using. So I thought I would create a notebook that would serve as sort of a prototypical example of that. And since I was going to create such a notebook, I figured I would share it as well. Another motivation is that the last time I went searching for a notebook that had some of the utilities I use, I encountered a fairly new website called data.world. Has anyone heard of data.world before? Oh, okay, a couple people. Good. So I thought that in the process I would introduce you to data.world as well. Essentially, data.world is sort of like GitHub for data. It lets you create data repositories. Different people can contribute to them. You can have discussions on it. It's really collaborating around data. Yeah, because I can't get to the network from my laptop, I won't show you there, but there are links there for those who want to explore a little bit about it. So I was also inspired by a tutorial by Josh Devlin called Turbocharge Your Data Acquisition using the data.world Python library. And I've actually borrowed liberally from Josh's online tutorial because he provides a nice introduction to some of the things here. Actually, without a notebook, yeah, I have a locally cached copy of this. Okay. And then the other thing, and I'm so far not doing so well at this. Was anyone at PyData 2015 in Seattle? Okay, not many. Did anyone go to my tutorial? Good. Okay. Yeah, so if you think this was a slow start, you should have seen that one. I gave a tutorial on Python for data science and didn't provide enough information ahead of time about what people should download and install. So it took quite some time to get off the ground, and I'm hoping we won't experience too much of that this time. But unfortunately, since I don't have a network, I'm going to be somewhat limited in my ability to follow along and help. Although there might be other people here who might be able to help if people have trouble. So anyhow, what happened in that tutorial is I had a tutorial I had already prepared. I had spent weeks preparing and given internally at the company I was working for at the time. And I ended up trying to squeeze that all into a 2-hour slot, and it was not very successful. So I ended up rushing through it all, not getting it to everything, and I didn't want to have that happen. So this time, I started out with a smaller topic, but then it grew. So we'll talk about some of that, but the main focus here is on using pandas for doing data analysis. And it turns out, so how many people here consider themselves experts in pandas? Okay, I'm not raising my hand either. How many people here consider themselves intermediate level pandas? Okay, how many people here are somewhat more beginner at pandas? Okay, I've included a number of links throughout this notebook to various documentation that might help those who are at the beginning or intermediate level even to learn more about it. So mainly what we're going to be doing is looking at data.world, and unfortunately we'll be using just the stuff from data.world I put in this notebook, but you can look around and browse yourself. And then we're going to go into a little bit about data cleaning. My experience in using almost any data set is never as clean as I expect it to be, even after I've cleaned it. And so I actually have a whole nother notebook about data cleaning for this stuff that, how many people here are interested in data cleaning? Okay, so what I'm going to do is reserve that for the end. What I did is there's a Python script in here called something like clean Simpsons data or something like that that will just magically do as much cleaning as possible. And then if there's time at the end and people are interested, I can go over a little bit about what I did to try to do that. But it's more the norm than the exception that the data isn't as clean as I'd like. Okay, so at this point I'm hoping that you have installed Anaconda. And how many people don't have Anaconda installed? Oh, good. Okay. Lots of hands went up at the last tutorial. I'm going to say a little bit here about Python 2 and 3, only that I still use Python 2 because that's the version of Python that we're using at Indeed. How many people here use Python 3? And how many use Python 2? Okay. I've set this up so that you should be able to run this notebook whether you're using Python 2 or Python 3. Okay? And I'm not going to go into a lot of details here, but just the only thing that you need to do in order to, if you're running Python 2 to be able to use this notebook is to import the print function. And while you're at it, or while I'm at it, I like to import the division function as well. And then that pretty much takes care of any of the compatibility issues that come into play in this notebook. Okay, so how many people, for how many people is this the first time using a Jupyter notebook? Okay, good. So you know how to already run things. So I'm going to just kind of go through here and import the usual aliases, pandas, aliasing it as PD, NumPy as NP, and then matplotlib, pyplot as PLT, and then what I want is for any graphs that we create to show up in the cell itself. Okay, so I'm not going to go through this in any great detail. I just actually gave a tutorial at Indeed to product managers, kind of trying to get them up to speed on Python and Pandas. So I'm not going to go into a lot of details here, but the basic, there's some information here about the basics of Pandas for anyone who's relatively new to it. It's a tabular two-dimensional data structure that can be manipulated with Python commands. The columns in the main data structure we'll be using is a data frame, which is the table. The columns are sometimes called series. We can access them using a variety of mechanisms, including slice operators. Other concepts that we'll be drawing on in this tutorial are grouping, the paradigm of split, apply, and combine, and then merging data sets as well. Okay, so ordinarily I would click on this link and show you the turbocharge your data acquisition using data.world Python library and or the Python SDK documentation and or the data wrangling tutorial, but you'll have to click on those yourself, or at least those of you who have internet access. So in order to install the data.world library, if you have Conda, you can do conda install -c conda-forge data.world-py. Has anyone done that yet? Okay. Has it worked? Okay. So if you pop over your command window, okay, so you would just type in, what did I say it was? Yeah, you know what? I'm just going to copy and paste it. Oh, actually, I guess there's probably a lot of people here who don't have Macs too. So whatever your preferred terminal window is. So you just type that into the command line and run it, and that should do the installation for you. Has anyone not been able to do that? Okay. Then I'm going to pass it along. Luckily, I borrowed a screenshot from Josh, and has anyone not created a data.world account yet? Okay. So you might want to take this moment to go out to data.world and create an account for yourself. Let me just see if this hasn't come back yet. All right. And once you go to that account, you should be able to go to your settings and then click on the Advanced tab and get an API token. Anyone having any trouble with doing that? Okay, whoops. Once you've got your API token, the next thing you'll do is type in dw configure, and it should bring up something like that. And then you just copy and paste the token from that window right there. Oops. Oops. How many people have gotten that far so far? Good. How many people need a little more time? Okay, I'll wait there a minute. And for anyone who's gotten that far, the next thing you would do is do pip install data.world and then in brackets, just like that, just copy and paste that line into your terminal window. Okay, well, I'm going to continue on here. There is the HTML file there if you get too bogged down on this. So I end up doing this time series analysis and other kinds of various analyses in Pandas on a daily basis, not so much the unevenly spaced time series analysis, on a variety of types of data that Indeed uses. But I thought it would be more interesting if instead of looking at Indeed data for this tutorial, we would look at something that's a little more generally accessible and well known. The Simpsons is a TV show that's been around for quite some time. It is, let's see here, there were some things. It is the longest running American sitcom and the longest running American animated program. And I'm assuming most people have at least heard of it, if not watched it. The data set for this episode, for The Simpsons was actually gotten through several steps. And I was going to walk you through some of those, but they originally scraped for one person's tutorial, who then made it available at GitHub, and then it was used by a Kaggle user, and then eventually it was uploaded to data.world. Okay, essentially there are 4 data files. data.world essentially allows you to host CSV files. And the 4 files there have to do with the Simpsons characters, the episodes, the locations, and the script lines. We're only going to be using the episodes and script lines for the purposes of this tutorial. So the first thing to do after you have installed the data.world Pandas library, how many people have finished installing that? Great. Okay, is to then import it, and then the convention for data.world is to import it, aliasing it as DW. So there's a few cells here in the notebook that are taken directly out of Josh's tutorial with permission. What happens is when you actually load the data set, it will create a locally cached copy of the files associated with the data set in a directory in your home drive .dw. Okay? So if you use the optional force update equals true option, you'll say go get the data from data.world and get the freshest data. I've already got it locally cached, so I would encourage you to run this now. It might take a couple of minutes to actually go fetch the data and upload it. Oh, I'm hoping this will still work. I'm going to give it a few more minutes. I don't know what will happen. I think what it does, it goes to see if there's anything new on the server, but I haven't thought about the fact. Ah. Okay. Well, I may have to actually switch over to my other laptop after all. Although actually, could I use yours, Alex? Yep. Fortunately, one of my colleagues has this installed on his laptop. So if you'll excuse me for a minute here, and I've got a loaner laptop here. So
the cells have been run if you want to clear it or something.
Okay, thank you. And then that's the password for that one.
Oh, okay.
What's that?
I'll just listen.
Okay. Okay, so Thank you. Oh, actually, it came back. Let me see if it actually, nope, okay. So, oh, Alex has, your scrolling is in the opposite direction of mine. Okay, so I'm going to quickly rerun the cells. Okay. Has everyone gotten to this stage? All right. So you can see that there's a cache of the CSV files. You can see the script lines file is much larger than the others. And we're now going to start, we're going to spend a little bit of time just looking at the data, and then we'll start doing some analysis. Okay, so there's lots of information associated with the various data sets. I'm not going to go through it all. The main thing that we care about here, since we're using Pandas, is that we have, let's see here. There's information about each of these files, and there's actually the most recent version as well as the original version, and you can explore that on your own. The main thing we care about is there's an attribute data frames. The data in a data.world repository essentially is available in 3 different formats. Data frames, tables, which are essentially lists, and the raw data itself. And we're only going to be focusing on data frames. I'll also note that data.world has lots of other things that I'm not going to be talking about. They have their own version of SQL called DW-SQL. They have Sparkle. They have a number of capabilities for actually querying the data directly from data.world if you have a very large data set that you don't want to try to copy to your disk. But we're not going to go into that because this is a PyData conference and we're mostly interested in Pandas here. Okay, so if you then run the various, if you then loop through the different LDS attributes, data frames, tables, and raw data, you'll get a little more information about them. The main thing we care about is the data frames attribute that we're going to use throughout this. And so to try to simplify things, I'm just going to copy the data frame associated with the CSV file, Simpsons script lines, into a variable that I'm going to use just called df. The first time you do this, are you getting a warning message when you see that? Okay. And I copied the warning message I got here, and right away it was like, uh-oh, looks like there's some noise in the data. And in particular, what this is drawing our attention to is that there's at least 3 columns, and actually more, that have mixed data types. And whenever I see that, it's like, uh-oh, there might be a problem here. So to try to figure out what's going on there, one thing we can look at is the Pandas operator or function info, which will give us some information about the objects or the different columns in the data frame. And we can see that there are a few that are showing up as just object. And that may be somewhat problematic. So one way that I go about trying to diagnose this, and again, I'm going to postpone or just entirely a thorough exploration of data cleaning, but I'd often like to see what kinds of things are in these columns. And so what I do here is I'm looping through, and for each column label, I'm going to print out the number of unique values the number of values that are null, and then the number of data types by just running the pandas apply function on the column label to extract the type of each element and then count the number of different types of values of, in this case, the number of different types. So you can see here that there are, there's a couple of things that are coming up with two data types here, timestamp in milliseconds, character ID, raw character text, raw location text, spoken words, normalized text, and word counts. So, and then another thing that I sometimes do is then I want to see a little more about what the distribution of these values is. So you can see we have a number of string and integer values here for timestamp. That's usually a warning sign. And then many of the others are a combination of strings and floats. And it's often the case, of course, that a string field, if it's not present, will just have the NaN value, the null value for pandas. So those are somewhat understandable. So again, I'm not going to spend a lot of time going through the data cleaning. There's a separate notebook I have here. Ironically, it's not very cleaned up, that you can look it through, or that we'll go through at the end if there's time. So here's the head of the data frame. Each row in the data frame has an identifier. The identifier is a unique identifier for this script line. There is an episode identifier, which is a number starting at 1. Number is the number of the line within the episode. Okay, so each time you have a new episode, number is going to be reset to 1. The raw text is the text that was extracted directly from the web scraper. And actually, the problems are with the data noise are mostly caused by quotation marks in various unexpected places that, at least the reading in a CSV file in the Pandas has trouble with. The timestamp in milliseconds, I actually meant to go and look into this a little more. I think it's actually the timestamp in milliseconds since the beginning of the season. If there's time at the end, we can look at that. There's an indication of whether it's a speaking line. There is, you know what I should do is, let me just print the columns here. That would probably make things simpler. There's a Boolean indicating whether or not it's a speaking line, because there are other kinds of lines such as, you know, stage directions, or, you know, sort of parenthetical comments about what's going on if you looked at scripts. There is a character ID, a location ID, and then the text, the raw text associated with each character and each ID. It turns out that the character ID uniquely identifies a character, but characters can have different flavors, right? So you can have Homer, you can have young Homer, you can have, you know, Homer's thoughts, you can have a variety of sort of slight variants that they're all kind of about Homer, but they're not strictly speaking Homer, perhaps, at least in the script. And locations can also have multi-valued, there can be more than one location text associated with a given location. The spoken words are, let's see if I can show you some examples here. Oops. The spoken words, so essentially each script line has a character, colon, and then whatever the character says, if anything. So if you strip off the character text, then you get the raw character text field, and then the spoken words is whatever comes after the colon. Okay? And the normalized text is essentially a lowercase version with most of the punctuation, but not all, which is another source of problems, removed from the actual text that's spoken. And then the last field is a word count field that indicates the number of words in that normalized text field. Okay, rather than go belabor how to clean up the data, if you just import the PyData Simpsons module that I included in that repository, and then run PyData or PyData underscore Simpsons, clean Simpsons script lines. It's a very specialized function that ought not to be used in any other context, and it's not even terribly well documented at this point, but I'll update the repository later. You should get a new data frame that's cleaned up a bit. Okay. Among the things that that did was that there were some lines that had values in the wrong fields. So there was one case where, for example, one of the timestamp in milliseconds was Springfield Elementary School. And again, it was because the quotation marks weren't parsed and everything got shifted. And then it also converts everything that are integers to ints. I use 0 for character ID and location ID, the null values, so we have ints. I just find it easier than having a mix of floats and NaN. The speaking lines had a mix of strings and actual Boolean values. And then perhaps the most important thing that I didn't realize early on was if you actually look at the ordering here, the first row in this data frame is actually not the first episode or the first number or anything like that. So I sorted them all by ID, which now gives us the script lines sorted in the order in which they occurred through the entire course of the Simpsons history represented by the data file. Okay. For some of the work that we're going to do, it turns out that the season is valuable. And the season of each episode is not included in the script lines, but it is included in the episodes. So we're not going to do any data cleaning or any exploration of the episodes data, except to note that it's got this season value, and fortunately, the values are all integers, so we don't have to really, or at least worry about that one. And I'm not going to go into all this, but there you can see some of the data in there. So we're going to the only thing we really need is season. And so what I'm going to do is merge the data frame that we got from script lines and the data frame from episodes. But again, since I only care about the episode, the columns, the season column, I'm going to grab that. But it turns out the ID field in the episodes data maps to the episode ID in the main data frame that we're using, the script lines. And so I'm going to retain the ID here for the ID column for the merge. How many people have used the merge operation before? Okay, so the merge is kind of like it's joining together. This is saying merge these two data frames, and the left on says use the column in the left data frame, in this case DF, that's called episode ID, and map it to the column in the right data frame, in this case DF episodes, called ID. It's going to do a left join, so it's going to preserve all the rows that were originally in the DF and just populate the season values wherever it finds them. Okay? And then I just use a little trick here where the suffixes, so now we're going to have two ID fields, right? Because the script lines has an ID for the actual line, and there's an ID in the episodes for the episode ID. So now we have two ID fields. I'm going to say the one on the left will retain, there'll be no extra suffix. The one on the right will have an underscore Y, which is the default value actually if you didn't specify suffixes. And I'm just going to drop the ID Y value because we already have the episode ID in the original data frame. I'd rather call it episode ID than ID X or IDY. The other thing, though, is that season now, well, here, I'll show you. Season is all the way over on the right, which, you know, is fine, I guess. But quite honestly, to me, season should be somewhere on the left, you know, closer to where the episode IDs are. And so that's relatively easy to accomplish just by simply renaming the column or reordering the columns by just specifying a different order here. So what I've done is I grabbed the column values, I copied them into here and specified them moving season from the end to the second position. And now when I look at the data frame, we get the season right there. Okay, questions? Yes?
Just talking about the column a quick summary of what does raw character text mean, or what raw location text?
Sure. So the script lines that this was scraped from had each line, and if you've seen a script, it says, character ID or character name, colon, and then something the character says. So in the scraping, what the person did originally is they wrote something to split the line where the colon is, take whatever's to the left of the colon and put that in the raw character text field, and take whatever to the right of that colon is and put it in the spoken words. And then whatever goes to the spoken words, it was then lowercase and the punctuation was removed to come up with a normalized version, which is called normalized text.
Okay. Got it.
Other questions on the data? Yes?
I got an exception a few lines ago. I could not load the data.
Oh, do you have an internet connection?
It gives me the integer NA problem.
Yeah, try updating your pandas, or try updating your pandas library.
Yeah.
I had the same exception and updated my library.
So conda update pandas?
Where he got a warning, I got an exception with the same error. And the finding values in finding mixed values in column something. Yeah. Down right there. So if you got a warning, you're fine. But I got an exception.
Thank you. I'm glad you figured that out. Other questions? Okay. I think I left off here. Okay. So, time series analysis is essentially analyzing data that has a time element. And usually the data is collected based on evenly spaced time increments. So per day, per week, per episode, per season, those kinds of things. And so we're going to start off here with just some simple time series data and analysis on The Simpsons. Oh, I thought I had put this somewhere. I guess I should have put this up further on. Anyhow, there's a sort of summary description of the fields in the data frame that we're using that was extracted from the Simpsons script line CSV, in case I overlooked anything or wasn't clear about that. Each data point in the Simpsons data has a timestamp, but also it kind of represents a different element of time. Okay, so you can think about it as that data itself is sort of an unevenly spaced data set, although we won't get into too much of that. The episodes data, each data point is an episode. Okay, a couple other things to note before we start manipulating it. Although there are 600 episodes in the episodes CSV, there are only 564 episode ID values in the script lines. So we're missing 36 episodes for which we have no scripts. And they seem to be unevenly distributed as well. So there's, let's see here. So we can say, show me the episodes for which the ID from DF episodes is not, using the not operator here, in the list of episode IDs in our main data frame. And that will show us the 36 episodes. Let's see here. There we go. So they seem to be scattered among, well, actually, I guess they seem to be in the upper 500s mostly. So we're just going to ignore those since we don't have script lines, and that's really our main focus here. Okay, so I wanted to make this a little bit interactive at least, although there is another notebook with, in big caps, answers out there in the repo. So if you want to peek ahead or you want to leave early or whatever else happens, there's a separate notebook there that has answers for all these things. But I thought it might be useful to at least give you an opportunity to do some exercises in Pandas on our way there. So exercise A, A1. I actually have 4 different exercise sets here. What are the minimum, maximum, and mean number of script lines per episode? Okay, so using the data we already have in the data frame, can you write the Pandas function or a single Pandas function, or a series if you want to, you can break it down however you want, that will come up with the min, max, and mean number of script lines per episode. And I include some links there to some Pandas functions that you might find useful for this task. So I'll give you a minute or 2 here to think about that and try a few things out perhaps. How many people have figured it out? Okay, I'll give you 1 more minute and then we'll start working through it a little bit at a time. Okay, so the first thing is we're talking about per episode. Okay, so because we want to find out something on a per episode basis, we're going to want to do some grouping, or at least that's the way I would approach it. If other people have other solutions after I show you how I would do it, I'm eager to learn too. Okay, so I'm going to say df group by and then I'm going to say episode ID. And that's going to create a Pandas group by object, which in itself is not terribly readable and often not directly usable as it's on its own until we carve it up a little bit. Okay, so what we want to know is the number of lines. So what this creates is a group of rows from the original data frame or actually a bunch of groups where each group have the same episode ID. Okay, so now I've got all these groups of script lines organized by episode ID, and I'd like to find out how many there are in each group. Okay, so there's a couple of different ways that we can go about this. One, well, here, I'm just going to create separate cells here as we kind of go along here so you don't, is we can use the size operator. Okay, and that will essentially show me for every episode ID the size of the group. Okay, so that's one way of doing it. Does anyone know of another way? Okay, if I use count instead of size, Pardon? So count also will give me the same number. So if you, so here, let me make this a little simpler by just saying, let's just grab the head so it doesn't get so overwhelming. And then we can look at them both. So size returns a series, a column, essentially, with the number of items in each group. When we call it on a group by object. Okay? Count essentially will also give me the number, but it sticks them in each of the columns. Yes?
There's like an inherent risk though in using size that if you had missing lines that you didn't know about, like for whatever reason they just got gapped. If you're missing 40 through 60, the size would appear smaller than the like total numbers.
That's a good point. So the observation is that one of the risks when we're doing this kind of thing is that if we have rows with nothing in them, for example, we could be overcounting. And you're right. And in fact, some of them have no lines. We could restrict it to the spoken, only the ones with speaking lines. And there's a bunch of things we could do to try to find that. And I think that's a really important thing to keep in mind. We're going to conveniently ignore that for now.
Like, I guess the approach I took to kind of account for that is I did episode ID, but then I indexed by number, and then I took the max. So it has a max applying number.
Ah, oh, that's interesting. Okay, so yeah, so let me first show you how I was thinking about it, and then I'll expand it then to the way you did it, which I think is an interesting idea, because then you're not dependent on if you'd had lines missing from the data. Okay, so I would use a similar idea, that is to say, I can take the ID field. So and then take the number of unique values for that, and again I'll do head. And then equivalently, and just for the benefit of people who are still kind of learning about using pandas, the exact same, using dotted notation, I can just say .id as well. Those are equivalent syntactic forms within pandas. So you're saying, and I'm going to stick with this one for now, because the notebook will highlight the strings that help set them out. So you're saying take the max number within that.
So sum out ID for number.
Okay.
The dot max. Yeah, right there.
Ah. That's interesting. So why?
I wonder if it's zero indexing. Yeah.
Oh, number starts at 0?
Yeah.
Okay.
So add plus
Yeah, but this is a particular for the number. So the other one is immune to this. You have to have a column called number, right? Yeah. Otherwise, the other one is unique to that. So it's immune to this.
Yeah. So if it was like count
Okay. So the advantage of this one is that if the CSV file itself was missing some rows, right, and you had gaps in the numbers, then essentially, assuming that the numbers were correctly calculated to begin with, then this might get you a more accurate reading. So, thanks. Other solutions? Yeah.
There is a rule out there, right? It says speaking line is true or false.
Yes.
You want to filter it by that?
I'm not. I could. I'm trying to keep it simple. So the suggestion is here, we're including non-speaking lines here.
Right, because that was the question. So I filtered by only speaking lines and resolution.
Ah, okay. So let me go back to my preferred way, only because I'm biased. There's no reason why it's better. Okay, so the suggestion here is if we want to just restrict it to, and I'll put it here so I don't forget, if we want, to only speaking lines, we can constrain the rows that we look at. And then actually in this case, we would want to actually count the number of unique IDs rather than the max number, because this would not allow us to do that. Okay, so How did you choose to constrain it?
So I did a aggregate on the speaking line, taking advantage of the fact that it falls to 0, and I just did like a sum. So dot ag sum, and then do an ag on how that gets.
Okay. I'm going to conveniently postpone the ag thing for the moment and just say the other way we can do this is it speaking line?
Yeah, speaking underscore line.
Okay. So what this does is if inside the brackets, what I've done here is I'm only returning the rows in that data frame for which speaking line is true. Okay. So it's just one less thing to introduce at this point, but okay.
There's also another way you can actually count the normalized text instead of ID. I use the normalized text.
I'm sorry.
I use the normalized text instead of the ID.
Uh-huh.
That. So that gives me even lower number.
Oh, because the normalized text when it's not null?
Yeah.
Okay. It's a lower number?
Yeah. So instead of ID, I don't even constrain that on the speaking line.
Okay.
I just count the number of unique of the normalized text.
Okay. I'm going to keep it like this, but I appreciate that additional way of doing it. Because actually I'm wondering if it's a speaking line and there's no normalized text, I'm wondering if that's pointing out another error in the data. So I'm going to stay away from that for now. But thanks for that suggestion. Okay. So now we know a variety of ways of actually figuring out what the number of speaking lines are per episode. So let me go back up and let's just, again, take my favorite prototypical example here. If we take this, and then we want to know what's the minimum number of speaking lines, we can use the min function. Whoops. Oh, right. So I can now say take all of those values that are returned, the different number of script lines on a per episode basis, and find me the minimum number there. And there's a max function. And, as you might know, there's a mean. Okay. And, as was noted earlier, there's actually ways, if you're computing a bunch of different statistics, there are ways of passing them into pandas and computing them all at once. Okay, there's an ag function that you can apply as well. So if these are the three functions I care about, then what I can do is call ag and then pass in the names of the functions, strings. And I'm going to do min, mean, max, because then that puts the mean in the middle. And get all three in a series. After the tutorial, or sometime later in the week, I will update with a new notebook of whatever we create here today, in case you're having a hard time following up. Okay. Well, I think I'll give you a moment here. How many people have used visualization functions within Pandas before? Okay. So essentially, many of the capabilities that you have in matplotlib for visualization are available directly as methods you can apply to a data frame. Okay. And one of those is hist. So exercise A2 here is to plot the distribution of the number of script lines per episode. Now that we know what the min, mean, and max are, what does that distribution look like? So I'll give you a minute here. Yes?
I, together with Pandas, am struggling with how your SEL97 works, because it seems to take an integer number of unique entries and then try to aggregate aggregate that over that integer. Before that, it seems to take a series and try to aggregate over that series.
So in this case, so.
I'm getting an error that series does not have an attribute ag for your line 97.
Do you have the latest version of Conda, of Pandas installed?
I have no idea. What's the latest version?
20.2, I think. Is that what we're up to? If you do Conda update Pandas, and it says you're all set, then you have the latest. Otherwise, it might be related. Is anyone else getting an error there about?
I just updated like 10 minutes ago, and it's giving me that error.
Huh. So it's n unique and not unique. Could that be a factor? There's actually a function unique, and there's another one n unique. Unique actually returns the unique values, and n unique returns the number of unique values, an integer. So has anyone been able to run this without error? OK. Who has run this, gotten an error, and has the latest version of Condas installed? Or of Pandas installed? Ah. OK.
I had 20.1, and I'm trying with 20.2.
OK. Note to self, I should have made quite explicit to get the latest version of Pandas installed. Yes, that work?
On an older version, the describe function will work. Instead of ag, it'll give you basically the same result. But if you do, instead of .ag, just do .describe, and it'll give you the max.
OK. That's good to know. The describe function in older versions of Pandas, at least, will give you the same capability there. Yeah, and actually, I'm trying to think, if you do Conda update Pandas, then you have to reload the library into your notebook, right? So you'll have to, so if that's the case, then what you should probably do, if you do Conda, so how many people who had the problem with that calling ag had an older version of Pandas? OK, so one way around it is you can restart your kernel, and then after pausing a minute, you can run all above, and it'll rerun everything up to that point. And that will include reinstalling, re-importing Pandas and the latest version, and hopefully that won't be an error.
That was my problem.
OK. So I will, you know what I'm going to do? I'm going to actually go right up here. Well, no, I will update that later, because then I'll get all. Did anyone do those steps? So Conda update Pandas, restart kernel, and rerun all cells, and did it not work?
It does work.
OK, good. Thank you. OK, so we left our heroes when they were going to plot this. I'm hoping you don't need more time, because this is sort of a straightforward sort of a thing. You either just plug it right in or you don't. So I think I'm just going to grab sort of our operating way of finding the number of unique values, and then just say .hist. Anyone have any problems with that? The visualization stuff is another area that's been under a lot of development lately. So there's more and more things that are available directly as methods versus doing the plot and then various kinds and so on within Pandas. OK. So a little bit of a stretch here. Now that you know how to calculate the minimum, maximum, and mean number of lines per season, or excuse me, per episode, how would you go about calculating the minimum, maximum, and mean number of episodes per season? So I'll give you a minute to think about that. And then I'll come back up here to where was it that we got the mean, min, max? Ah, there we go. So I'll put this down here. You may find that as a useful guide. I'll give you another minute here. Yeah.
So I just experimented with using the Pandas SQL package.
Mm-hmm.
For me, coming from a SQL background, it's easier to work with than methods like GloBy and so on. From a performance perspective, how do those two compare?
I have not used, so the question here is how does this SQL methods or function within data world work compared to, oh.
Like Pandas SQL.
Oh.
Yeah, like outside of their world.
I don't know.
Okay.
I use Pandas pretty exclusively. Does anyone here know how they compare, or is it mixed depending on what kind of operations you're doing?
So I think it's using, there's another older one called eval that Pandas has, and it's using that one. Sometimes you can get a speed up on especially numerical operators. I don't know if SQL's using that.
Okay. It seems to work functionally. It always work for.
Okay, so in this case, we were counting essentially the number of unique IDs associated, and where each ID is an identifier for a different script line after grouping by episodes. What are we going to want to group by this time? Okay, we're going to group by season. So we're going to replace episode with season. And then within each season, what is the thing that we want to know the number of unique values for? Episode ID. Okay. So the smallest number of episodes in a season was 13, the highest was 25, and the average is close to 22. And then I'm assuming at this point it's a fairly straightforward copy and paste operation here to plot the distribution, there. We'll just plug a hist at the end of that, and we get our plot. All right, one more pair of exercises along this vein. What are the minimum, maximum, mean number of characters appearing per episode? And I'm assuming this one is even more straightforward. Oops. What are we going to group by this time? We're going to group by episode ID. And then what is the thing we care about here? Could be one of two things, right? There's two different fields that are focused on characters. Can you use character ID? Or what else can we use? Raw character text, right? Because there's a, somewhere in this notebook, I kind of sketched that out a little bit further. There are sometimes several character text values associated with the unique character ID. Okay, doesn't seem to have much effect on the overall distribution of data, though. And then, just to round things out, we can plot that distribution as well to get a sense for the number of characters that appear on average per episode. Question? Okay. What I was finding as I was going along and preparing some exercises for this is some of the more interesting questions that arose were things more about the characters than, say, the script lines or the episodes. It was really things about, you know, how often do people appear and so on. What I found is I kept on rerunning these pandas operations to group and select and do all these things. And what I really wanted to do is have a data frame that was that I could use to manipulate. And so I put together a set of exercises here, and I think I'll run through these a little bit more quickly because they're not really so much to do with analysis as much as constructing a data frame for subsequent analysis. But I found it kind of a useful set of tricks or techniques that you might find generally useful. So we're going to put together a data frame that is going to have the number of lines that's going to have information on a per character basis rather than a per script line or a per episode basis. So the idea is each row is going to represent a different character. Okay, and one thing, here we go. So one thing to point out here is the number of raw character texts is different from the number of character IDs. Okay, and we can get a sense for what that looks like if we group by the character ID, and then we, instead of taking n unique, we actually use the unique function, which returns a list of the unique values within a group. Okay, and here you can see, for example, that for character ID 1, we have Marge Simpson, but we also have young Marge, Marge's thoughts, and so on, just to give you a sense for what the different character text that might be associated with a single ID look like. Okay, so I think it's useful to be able to create a table, to have this grouped by, we have a row for each character text. And that way we can still regroup by the character ID if we only want to use character ID, but we at least have a fuller set of information. We don't have to worry about lists of values in certain cells. We can keep things simpler in that regard. Okay. So what we're going to do then is we are going to create something where we have a character ID, a raw character text, and then just to get started, a column indicating the number of script lines associated with each raw character text. Okay. And the way we're going to do that is we're going to group by, in this case, two things. We're going to first group by character ID, and then secondarily by raw character text. So now each group will share a single ID and a single text. We'll have more groups than we would if we only grouped by ID. Okay. And so what you see there is we get the rows that we're looking for, including the null character, essentially the character that has, and again, we're going to conveniently ignore the speaking lines and other complications here. Okay, so and again, so I actually created this one before I created the other set of exercises, so I'm duplicating myself here, but this is syntactically identical. Okay, so what we did up here is it's not syntactically identical, but it's functionally identical, right? We take the size of each group, but if we also just count the number of unique IDs, we essentially, because we know the ID values are unique for every script line, we get the same result. And then I'll also note that here I'm inserting a reset index just to pull things down from a multi-index into a single data frame. Because I get all balled up when I try to use multi-indexes. I try to convert them back to data frames as soon as I can. Okay, so if we do this operation here, let's see here, I guess I will pull this down so it's all visible. Okay, so now if we group by character ID, raw character text, and then count the number of unique IDs, reset the index, whoops, let's see here. We can then rename the columns because, as you can see here, what we end up with is because we're selecting the ID, this is kind of number unique, we're getting a column called ID, which is not very helpful. In fact, it's even misleading, given what the value represents. And so what we're going to do is we're going to rename the column called ID to numlines. which is the number, which is actually the thing we're counting. And then we're going to assign that value to a new data frame we'll call df characters. Oops. And then let's see what that looks like. Okay, so it looks pretty much like the other ones, except we now have a column named numLines, and we've stored the result in a data frame. And then if we want to find out who has the most lines, we can use the sort values function on a data frame, pass it in the thing we want to sort on, and then say, show it to us in descending order. So surprise, surprise, Homer Simpson has the most lines. The null character has the second most lines. It turns out Homer has twice as many lines as Marge. And in fact, if you go follow the links to the original blog post, one of the things they were looking at is gender distribution and the frequency with which different characters had numbers of lines and so on. But I'll leave that as an exercise beyond what we're going to do here. OK. If we want to exclude that, let's see here. Let me pull this all into one. Is that all? Yep, OK. So we could also, using a similar technique we used before, is we could constrain the rows that are returned to only those rows for which the character ID is greater than 0. Or alternatively, equivalently, the raw character text is not the empty string. OK, and then we find out that Milhouse is the 10th most, how should I say, verbose person with the most lines in the seasons here. OK, so try to decide here, if we run out of time here. I think just for the moment, we'll try this first exercise and then kind of race through the others. And I think once you get the first one, the rest will become clear. But I sometimes get all balled up using merge effectively and pulling things together. So now that we have a data frame with df characters that shows the number of lines for each character, how would we go about adding a column that counts the number of episodes in which each character appears? OK, so I'll give you a few minutes to try to work on this, and then we'll go ahead to the answer. You might find it useful to break this down into 2 steps. In the first step, you might create a new data frame that contains the number of episode ID values associated with this raw character text. And you might also use some techniques we used before. And then merge that into df characters. So now, instead of having a separate data frame where you have a new, an entry for each raw character text and a number of episodes, you actually have a single data frame, df characters, which has number of lines and number of episodes. So I'll give you a minute to think about that and work on that a little bit. This is also in the answers, and in fact, I have a whole function that will pull this all together if we grow too tired of it. How many people have figured it out? OK, give you another minute or 2. How many people figured out how to do the creating another data frame part? Okay. How many people would like a little more time? Okay. All right, so step one is to create a new data frame where we can have the number of episode ID values with each raw character text value. So based on the earlier example, we're probably going to want to create some groups, right? And what are we going to want to group by in this case? Raw character text. So we're going to say group by and then what we care about, though, is the number of unique episode ID values associated with each of those groups. Okay? So how are we going to figure that out? What are we going to put here? And then, and unique. And then just keep it all readable. Oh, actually, well, yeah, what the heck. So what that shows you is a multi-index object that has the values that we care about. Jump stamp the ticket man occurred in 5 episodes. Interesting. Okay, and so, as I said, I generally try to get out of multi-index land as soon as I can when this kind of thing occurs. So I'm going to say reset index. And then we go from a multi-index back to a data frame. Yes?
Don't you want to use raw character text and character ID so that you can have the same primary keys when you do the merge?
Yes, except that I already found out that I know for a fact that any raw character text is associated with exactly one. But you're right. I would definitely want to group by both of those so I can be sure of them. But in this case, we're safe. Okay, so the data frame. Now we want to merge it in with the existing data frame, which we're calling df characters. So we'll say df characters merge, and then we're going to merge something into it, and essentially what we're going to merge into it is that data frame we just created. So we could set it to a variable df temp or whatever, but I'm just going to, it's really just a throwaway, so I'm just going to grab this. Oh, here's what I should do also. I should show you that okay, there are 6,764 rows in this data frame. And just to be safe, we have the same number of rows. Okay? So we're going to merge. Oops. This data frame, let me see if I can add a few, get rid of the head. Whoops. Okay, so we're going to merge the data frame created by this group by operation we just did. And what are we going to merge on? raw character text. We know they have the same amount of values, but I generally default to using left as a mainstay. Okay, so that gives me a new column. Anyone see anything wrong with that column? Yeah, it's called episode ID. What would be a better name for it? Num episodes. All right, so let's grab this and call rename again. And columns equals episode ID colon num episodes. Oops. That's all. That's a dictionary. Okay, so now I've got a new merged data frame. And the only thing I need to do now is to make it the new value of df characters. I don't think there's an in place for merge, is there? I don't think, anyhow. Last I looked, there wasn't. So now I'm going to grab everything but the head. There are a number of times where I've forgotten to lop off the head, and I end up having a very small new data frame and having to rerun all the cells. So that's happened enough times where I'm very careful about that kind of thing, usually. Let's see if I do it here. Okay, so now I'm going to say df characters equals that. And just to make sure, df characters has the desired fields. Questions? Is this a useful exercise? Yes.
So I'm sorry, I got a little bit lost. When you had to rename that column, why did the meaning of the column change as a result of the operation you did before the rename?
So the question is, why did it end up with episode ID as the column name to begin with? I think it has to do with when I reset the index, it just pulls it down. But that's a good question. I don't know why it does that.
So I think when you're doing the aggregation, when you aggregate on a column, it defaults to naming it the column you're aggregating.
Ah, okay.
So the series name that you created had the name of that column.
Okay, I don't know if you heard that. So Alex just explained that when you do an aggregation, the default is just assume if you do on a single column, you just grab the name of the column that you were aggregating on.
So is there a way to name that thing at the initial time you did the aggregation, or do you have to always do this as a subsequent rename?
That's a good question. Does anyone know? So the question is there a way to do renaming right when during the grouping, right? Or during the n unique? Yeah.
When you're creating the series in n unique, you can rename the series at that time, so that once you join it.
So before I do the reset index here, I could rename here.
You can rename the series.
Using the same method, rename.
In that case, just rename and supply the new string to the series.
Okay. Let's see what that looks like. So the suggestion is here we say rename. And like that. Whoops.
Oh, because df characters is already been reassigned.
Oh, right. Okay. I'm not going to rerun everything now, but but thanks for that tip. Now, actually, I'll try it the next time around because we have other exercises like this. Yes. Oh.
Name equals episode now, and then we'll label the column automatically.
Okay. So another way of doing this, and it's not going to work, of course, because of the fact that we already have a value here, but we can use it, is instead of renaming this way, we could pass in a parameter here, like that. Are my parentheses? Okay. Cool. Thank you. I get to learn some stuff. Other questions or comments? Okay. Let's do one more exercise, and then we'll just kind of race through because the others are pretty easy, and we can just run the actual utility function to do it, just so we have some time for questions at the end. Oh, there's actually one more thing about uneven time series analysis. Actually, yeah, I forgot that we haven't even gotten to the next two sections yet. So what I'm going to say for now is you can work out the other exercises on your own, and or look at the results there. But if you just call this cell right here, you can use the solution that I created in the PyData_Simpsons module, the Py file in the repository, and it'll take care of all those things. Okay, so when you run that, you should end up with something that looks like this, where you have the number of lines, number of episodes, first episode and last episode IDs, the number of seasons, and the first and last season. Anyone not have that? Okay. Okay. So there's just two more sets of exercises here. One is just a quick one. Now that we have a data frame for each character, can you figure out the minimum, maximum, and mean number of script lines for each character? Actually, what was that? And using the the DF characters data frame. And because we're going short on time, I'm just going to put this in here. We're going to use the same. Oops, something didn't colorize there. Okay, and then there's other things you could do about, you know, first and last and num seasons and so on, but having aggregated everything together in a data frame makes it easier to ask certain kinds of questions now. Questions on DF characters? Okay, so we're finally at the section that was advertised in the abstract, which is unevenly spaced time series analysis. And what's different about this kind of analysis than most time series analysis is that what really matters is the intervals. It's the gaps between things over time that turns out to be the case. I end up doing this occasionally, but not so often that I forget, which is sort of the main motivation here. So examples of what we've done at Indeed. So Indeed has a new organization called Indeed Hire. How many people have heard of Indeed before? Oh, good. Okay. So Indeed is the world's biggest job search engine. We have tens of millions of jobs. We have tens of millions of resumes. And what we basically do is we try to match them up somehow, either for employers or for job seekers. We have a new business called Indeed Hire, where we have recruiters. We have a team of recruiters that will make those placements, which has been great because a lot of times, Indeed, we try to figure out how, we look at the data and try to figure out how did that get there, why does that look like that, and now we can actually talk to people who work for Indeed and figure out why they do the things they do. So one of the things we've been looking at are things like how often do we have repeat business from existing clients, and then we often look at that to see the intervals between the dates on which a new job requisition was created. And then, because we have different ways of defining it, sometimes a client will start up a new job within a day or two of giving us one, and that's not counting. But then, how far out do you go? Do you go a week, a month, and so on? So, you know, being able to kind of look for the intervals is actually important there. And the other kind of thing I end up doing sometimes is when our recruiters review profiles, we try to figure out, well, how much time is that taking? How much time are they spending actually dispositioning profiles? And some of them are very fast, and it depends on the jobs, of course. So looking for the time intervals between each disposition state change during profile review is one way to try to get a sense for that. And then, of course, we have to tease out things like where does the session end and so on. All that said, rather than try to trot out a bunch and having to explain a whole bunch of the Indeed data, we'll stick with the Simpsons data. And we'll look for scene changes. I don't know quite how to find scene changes per se, but one way that we might approximate it is to look at, well, if you've got a new location, right, is one way that you might look at it. It's probably going to have some noise in there too, but because sometimes it goes back and forth quickly, but that might be one way to do it. It turns out there are 407 rows in our original data frame where the location ID is 0. Fortunately, those are also the ones where the raw location text is empty, and they happen, and they'll co-occur with each other. Okay, so just, again, there's some noise. There's still some noise in the data, even though we cleaned up a bunch of things. Okay, so here's some examples of lines where there is no location. Okay, and we could go in and try to look for some ways of interpolating this. And in fact, I started down this path in this separate notebook of data cleaning. But it turns out a lot of these things are some of these things at least are due to just, munged up quotation marks in the original CSV file. So even interpolation may not be a good way of handling it. So with that understood, whoops. Can you still hear me? Okay, good. So it's also the case, just like there are some location IDs that have, or some character IDs that have multiple character text values. There are also location IDs that have multiple location text values. Okay, and that one of the things is that they're not all lowercase. They're not all normalized is one reason, but there's other ways of referring to the same thing. Okay, so there are some of the most frequently occurring locations. The Simpson home, the school, the tavern, and so on. And then at the other end of the spectrum, we can look at some of the infrequently occurring location raw location text values as well. And you can see there that we have a mix of all uppercase and mixed case as well. Okay, so how many people have used the shift function in Pandas before? Okay, this is actually something that Annette introduced to me when I was struggling with banging my head against trying to figure out how to do some of these analyses earlier. She said, oh, have you tried shift? I was like, oh, no, okay. So one way that we might identify location changes is look for changes where the location of the current script line is different from the location of the previous script line. Okay, so again, we'll look at just the first few rows of our data show that the locations are 1, and then there's 4 lines associated with location 2. Okay, if we apply shift to the location, what that does is it shifts everything down 1. So this 1 now shows up in the second row of the shifted series. Okay, so we get a 1 there, and then these 3 2s show up here on rows 2, 3, and 4 instead of being on rows 1, 2, and 3. And then because there was nothing by definition before row 0, that's a null value. Okay, and then just to, we could also shift up. So I should probably show you more in 5 there, but now you can see that by using shift -1, you can shift things in the opposite direction. And you can do more than 1 values. And you can actually shift by time, for date time, all kinds of time offsets. There's lots of, it's a very powerful function, but we're not going to go into all that here because we already have everything organized into rows. And all we really care about is shifting things a little bit. Okay, so first we will group by episodes. And it looks like I must have done this later. I'll try to be consistent internally here. So if we first group by the episode, and then we take the location ID field and we shift it. Oops. Oh, I forgot to put a period back in. Okay. So it turns out, because we had previously already sorted the data frame based on IDs, all 5 of the first lines in the script are essentially from the first episode, so we get the same value. So what we can do here, though, is, again, because I like working with ints, this only works because there is no location 0. If it was a 0-based indexing system, then this would not work. But because it is a 1, the numbering starts at 1, and we can count 0 as null values. We can essentially do the shift. We can use fill NA, fill the null values with 0, and then convert everything to int 64. Okay, so now we get a field with ints in it, with zeros substituted for the null values. And then we can add that into the main data frame by essentially referencing a new column name with the value of, let's see here, just so it all shows up on the screen, of that last thing, last line. And then I won't show you the full data frame, but there you can see that everything's kind of shifted down 1. Okay? So now if we went through, whenever the location and the location ID and the previous location ID values don't match, we've got a scene change, more or less. I mean, I'm conveniently forgetting the fact that we have a bunch of zeros. There's 407 rows, right, where there's a script line and there's a 0 location. But again, for the moment, we'll just conveniently forget that. Okay, so final exercise. Oh, did I already do it? Well, isn't that convenient? Okay, so how many scene changes are there across all episodes? What we can do is just we can constrain the data frame looking for the rows where the location ID and the previous location ID are not the same, and then just take the length of the resulting data frame. Okay, so it looks like over the course of the history, there are 17,000 or so scene changes. And just to kind of double check, whenever I do something like that, I kind of like to see, well, what's the flip side of that? What are the number of rows where they are the same? And that should be a high number, and unfortunately it is. So I guess it was in a way fortunate in that my intention was to end by 11:45 so that there'd be time for questions, comments, or early lunch line. That's the end of the notebook. I'll stop there and open up to any questions. Yes?
So if you were to do this in SQL, you would use like a window function to shift things. Part of that is grouping by location and then choosing like an order by. I think by default, is just ordering by whatever the data frame's already sorted by. Is there any way to specify how you want it ordered when you're shifting?
That's a good, so I'm sorry, you want to be able to change the order of the shift?
So in case your data set was maybe not sorted properly or something like that, is there a way within the shifting itself to tell it how you want it ordered when you're going one back or one forward?
I'm not aware of one. I would probably sort ahead of time, either in sorting the data frame or apply a sort operator somewhere along the line in the chained calls.
Okay.
Question over there.
When you have a lot more data, let's say millions or millions of rows, and what are you going to do to perform all these operations? Was that
So the question is, what do you do when you have big data instead of small to medium-sized data like this data set? Are you asking specifically about the shift operator or in general? Yeah, that's a good question. I so far haven't tried to apply this on a data set that's more than, say, 1 million records, which is still, at most medium. So I haven't exhausted memory or run into all kinds of problems. So I haven't encountered that. Does anyone have any suggestions generally for how to deal with that?
Distributed.
Dask. Ah, Dask. Isn't there there's a DAS tutorial later today, right? Ah, okay. So that might be a good question to address there. Other questions? Yes.
Hi. Oh, thanks. This was a fun tutorial with the Simpsons application.
Good,
I have a question about the final output of like your two examples with Indeed or the Simpsons. Mm-hmm. So now that you somehow kind of made consistent these uneven spaces, how do you show the time series, or how's that applied?
So in the example of where I was looking for the gaps between new requisitions from the same client, what I actually was using was not integer like orderings, but actual date time values. So I essentially had the dates of these things, then I could use the Pandas ways of manipulating offsets and count the number of days, and then divide that by 7 if I wanted weeks or other kinds of mechanisms to try to get a sense for that.
Okay, so the final output of this analysis is essentially like a metric that you're looking at, not a time series?
Yes, so in this particular case, what we were trying to find is count the number of distinct requisitions that represent repeat business versus new business.
Okay.
And so what the key was trying to filter out when we have more than one requisition, that they occur too close to the first requisition, we want to discount them, and then different people had different ideas about what that should look like. So we wanted to see how the overall counts would be affected for sales numbers.
Okay, thank you.
Mm-hmm. Other questions? Yes?
At the very end, you used location, colon, and then the new column name that you were assigning.
Yep.
Is there a good explanation why you just don't do the brackets at the end? That was like a common way.
Yeah, so the question is for, let's see if I can find it here. Why was I using the loc function rather than just the bracketed way of referencing columns in right here? The reason is I've just gotten into this habit. I don't know if I needed to here, but I keep getting these warning messages whenever I do these assignments just using the old way of bracketing things, because it's either a copy or a panel or a view. And so I've just gotten into the habit of referencing things via the location when I'm using labeled versus positional references. I don't know if it's necessary here. It's just a habit I've gotten into. Other questions? All right, thanks. Don't forget, we're raffling off for drones. Stop by the Indeed booth. And if anyone's interested in working at Indeed, please come see me or any of my distinguished colleagues here. Thanks.